It is a non-linear mixing technique between the information carrying signal and the locally generated signal. Okay. So what is coherent system? So it is a non-linear mixing technique between the information carrying signal and the locally mixing generated signal. Okay. Are we clear? And then after, for the condition and the for condition, uh, for condition of the coherent light, for the condition for the coherent light, two light wave meet the following condition. Three condition at of transmission. The first condition is that frequency is same. For the coherent things, the two waves have a same same frequency. The vibration direction is same. Okay. The phase difference is constant. Phase difference is constant. Okay. Frequency is same. Vibration in same direction, or the phase difference is the constant. Okay. So the phase difference, this one is the phase difference. Okay. Frequency and wavelength, frequency or wavelength will be same. Amplification may vary. Amplification may vary. So these wave are different amplification, but the same phase and the in same direction. Okay. A two type of wave, a constructive, this one is constructive, one wave, second wave. Okay. Destructive mean if wave in direction, another wave in opposite direction. Okay. So this one is destructive one. Okay. There are homo there there are homogeneous lambda 1 lambda 2 and the heterogeneous where lambda 1 is not equal to lambda 2. Okay. New signal for the homo coherent optical communication system is one which receives the optical signal is mixed with the locally generated laser signal. Okay. A coherent optical communication system is one which when we receive the optical signal is mixed with the locally generated laser signal. Okay. And the mixing allows the receiver to detect the amplitude, frequency, and phase of incoming optical signal, not just intensity. It gives a high sensitivity, long distance, and higher data rate. Okay. Why it is called incoherent? So because the receiver use a coherent optical wave from the local oscillation to mix the incoming signal. Okay. This mixing produces an electrical signal to RF or the baseband to mix the incoming signal. This mixing produces a electrical signal. Okay. Fundamental of the key fundamental are optical mixing, local oscillators, sensitivity improvement. Okay. And can be use advanced modulation technique like PSK, QPSK, 16 QAM. Okay. uh, Types of the coherent detection. So two types is heterodyne and the this one heterodyne heterodyne like this one, the homodyne. So heterodyne in which local oscillator and the signal are in same local oscillator and the signal are the same frequency. Okay. And produce a baseband output and highest sensitivity but diff, but difficult to implement. Okay. And heterodyne in which the frequency is different from the received signal, the frequency different from the received signal, produce an intermediate RF frequency. Okay. So here that there are, we can see and there are homodynes. Okay. In which the lambda 1 lambda 2 is equal to equal, and the heterodyne where lambda 1 and lambda 2 is not equal. So new signal for the heterodyne detection, new signal for the heterodyne is the intermediate frequency appear as a microwave frequency range. So produce an intermediate radio frequency. Okay, the intermediate frequency appear as a microwave range. Okay, so infrared as a IF as a difference between the frequencies of incoming signal and the local oscillator. So IF as the difference between the frequencies of incoming signal and the local oscillator. Okay, adds to the incoming optical signal from the locally generated optical wave prior to detecting the sum. Okay, hence the resulting photocurrent is a resulting photocurrent is a replica of original signal and translate the the conventional electronic technique used for the further signal processing and demodulation. The ideal coherent receiver operating at 1.3 to 1.6 micrometer and the wavelength which required a signal energy from the 10 to 20 photon per for the BER of 1.1 10 power minus 9. Okay, it improved the receiver sensitivity and SNR and increased the repeater distance. Okay, it has the advantage of a longer distance, larger transmission capacity, WDM technique support, increased power budget to be compensated for the losses at a coupler and the optical mux and demux devices. Okay, this we explain and this we explain these are the explanation of the coherent one. So what we write we have to understand in detail further. So first understand what is the building block for the element. Okay, generic coherent optical system. Okay, electronic device and drive electronics. So here is the okay block diagram of the coherent one. Data is transmitted inside the electronic devices. Okay, then after modulator the frequency amplitude, frequency, phase and polarization is checked. Okay, and this is one lambda 1. Okay, so if it homodyne then lambda 1 lambda 2 and all are equal. If it heterodyne then lambda 1 is not equal to lambda 2. This is single mode fiber link. Okay, after that or this is a continuous wave CW continuous wave laser. All are providing from this the lambda 1 is coming, this one lambda 2 is coming, so laser control. Okay, laser control and giving this one a single mode fiber. Then after the lambda 1 is detector response to the optical field, detector responses to the optical field in a lambda 1 and the simply an amplifier, and after the demodulator that is heterodyne and the data out. So amplifier is a local oscillator controller. Okay, local oscillator local oscillator control laser local oscillator. You have lambda 2 amplifier and demodulator where heterodyne things happen and the data is out. Okay, this is the transmitter side, this is the receiver side. Okay, so first and let's see let's see what we have noticed here. First of all what happened here. uh, First of all, when a data is given to an electron and device electronics, okay, then modulator things placed here in which frequency, amplitude, phase and polarization is checked. Okay, and thereafter a continuous wave laser provide a different frequency through the laser control. Okay, this is a transmitter continuous wave laser which a frequency is passed through this one. Okay, and we get lambda 1 from this side. Okay, and lambda 2 from the this side. Okay, so lambda 1 and lambda 2 we are getting from the lambda 1 is going from here, and if detector responds to the optical field, we go to the amplifier portion, and the local oscillator control these things to the laser local oscillator give a lambda 2. If lambda 1 and lambda 2 is equal to equal to, and then it is homodyne. If lambda 1 and lambda 2 is different, it's heterodyne. A single mode fiber link. Okay, amplifier and the demodulator is heterodyne. The data is out. Okay, this one is a transmitter one, this one is a receiver one. Okay, so these things happen. So it is optical transmitter and optical receiver things. Okay, so it support modulation. It support ASK, FSK, PSK modulation format. Okay, coherent system consists the modulation technique like ASK, FSK, and PSK. Okay. So coherent system blocks. Let's discuss the coherent system blocks. So we have discussed. Let's say inside this one. So there is a transmitting portion. There is CW, continuous wave, a narrow line with semiconductor laser optical frequency oscillator. So CW is known as so let's discuss. This one is CW, continuous wave. So continuous narrow line with semiconductor laser and optical frequency oscillator. Okay, external modulator wavelet drive fabricated from the lithium nicobate compared to the semiconductor. Amplitude frequency phase shift gain of the optical carrier by the information signal transmitter side. The optical fiber is linked, and the receiver side incoming signal combined incoming signal combined combined or mixed with the optical output from the semiconductor laser. So incoming signal combined with the incoming output signal from this one. Okay, optical output from the semiconductor laser local oscillator. Okay, combined signal fed to the photo detector. Combined signal is fed to the photo detector. The detector responds to the optical field. Okay. Okay. Combined signal fed to the photo detector for the direct detection in the conventional square law device. Okay. There's two type of things happen there. There's a homodyne in which lambda 1 and lambda 2 is equal, and heterodyne in which lambda 1 is not is equal to lambda 2. Okay. So lambda 1 is the incoming signal and the lambda 2 is a local oscillator laser output. So lambda 1 is the incoming signal. So as we see the lambda 1 here, we see lambda 1 as a incoming signal. Okay, lambda 2 we see here is the output, and the output of laser local oscillator is the output of laser local oscillator. Okay, local oscillator laser output. Okay. Mm, and the coherent, now we have understand what is coherent coherent system. Okay, and now we have move forward for the coherent detection things. Coherent detection principle. So coherent detection principle, it is a technique to it is the technique to receive the data from the modulated signal. So coherent detection technique to receive the data from the modulated signal by using photodetector and local oscillator. Okay, so it is a technique to receive the data from the modulated signal by using photodetector as a local oscillator. Okay, a basic coherent receiver model is taken which work on the square law demodulation technique. A basic coherent receiver model is taken which work on the square law demodulation technique. Okay, so incoming signal treated as es is equal to es cos omega s plus theta. Okay, so after that a local oscillator give a local el is equal to el cos omega t. Okay, local oscillator give the el cos omega t as a local oscillator. The low level incoming signal field es combined with the larger local oscillator combined with the larger laser signal field el. So what happened when they mix and the incoming signal combined with the laser oscillator combining this one. Okay, the low level energy coming from this one and the combined with the larger local oscillator laser el. So like this one. Okay, then the heterodyne detection, the local oscillator offset for the incoming signal to ws by the intermediate frequency will be omega l plus omega lf if. Okay, after the phase difference s minus l for the source minus laser one, this one. So E has a peak incoming signal. So E has defined the peak incoming signal field and the peak local oscillator field, incoming signal field, peak oscillator field. WL stands for the local oscillator angular frequency. WS is angular frequency, the angular frequency of local oscillator angular frequency and the incoming signal angular frequency. Okay, incoming signal phase, local oscillator signal phase. Okay, so we understand all this parameter. Okay, and we know that the information contained in the variation. So we know, that the information contained in the variation of ES for the ASK. To further the heterodyne condition in which the angular frequency of the incoming signal is equal to with the angular frequency of this one WL and uh, intermediate frequency, and WF is the intermediate frequency. So intermediate frequency is equal to WS minus WL. Okay, for the homodyne WS is equal to WL, so the intermediate frequency is equal to 0. Furthermore, the optical detector produces a signal photocurrent IP proportional to the optical intensity. So in furthermore, optical detector produce a signal photocurrent IP proportional to the optical intensity. So square of the total field for the square law is equal to, and the produced photocurrent is directly proportional to the incoming, the photo current is equal to Es by Al ka whole square. So IP, which is proportional to the optical intensity square of the total field of the square law photo detection process. Okay. So yeah, putting the values now, substitution of expression this one. So Es cos of this one and El of cos of this one and square. By assuming the perfect toxin expression, the right hand side of expression look like this one. Uh, this one. Okay. A square b square 2ab. Okay. After that, half of this thing happen, and finally the result will be this one. So removing the higher frequency. So removing the higher frequency term, the oscillator nearly frequency of 2 omega s and 2 omega l. Okay, which beyond the response of detector, and therefore we do not appear into the output we have. So IP is equal to half of EF square, half of EL square plus 2 times ESEL cos of omega t, omega s minus t, omega l t by 5. Okay. So they recalling the optical power content, the signal is proportional to the square of electrical field strength. Okay. So we can say that IP is directly proportional to PS plus PL plus 2 root under PS PL cos of omega ST as omega LT plus 5. Okay. And PL and PS is the optical power of the incoming signal and the local oscillator signal. Okay. Furthermore, the relation was obtained between the output photocurrent from the optical detector. The incident power P naught is equal to IP is equal to eta E. Eta is P naught by HF. Okay. I is equal to eta E HF PS PL. This one things. Okay. And is a quantum efficiency of photoelectron. E is the charge on the electron. H is the Planck constant. So the final result for the heterodyne where omega s is not equal to omega l. So final result will be this one. So R is proportional. R is the responsivity of the optical detector. In this case, the output for the photodiode based on this one. Actually, this one after combining, so by quantum efficiency, we can see that this one for the incoming data signal we can find. So this is a full derivation of this one, and finally we can write that the incoming signal, we can see that finally R is equal to 2 times R root in the PS and PL cos of phi. Okay, so the optical and detector condition. Okay, so we have to know this one only. Okay, optical detector condition, we get expression from this one. And now we modulation and demodulation scheme. Now we see the modulation and demodulation things. Okay, so we have some modulation technique. So direct modulation is when the current before reaching the laser diode. Okay, direct modulation technique. Okay, so in which a current before reaching the laser it modified with the desired signal for the application. This use a function created to create a modulation signal and the laser diode driver to apply a signal to drive the current from the laser. Okay, First one direct modulation and the second was external modulation. So okay, direct modulation is which the current before reaching the laser diode is modified with desired signal for the application, and this use a function generator to create a modulation signal and the laser diode driver to apply a signal to drive current for the laser. So we can see that so direct modulation, we can explain direct modulation as simply direct modulation mean that you can change the current going into the laser diode and automatically modulate the light output of the laser. Okay, so direct modulation means you can change the current incoming, change the current going to the laser diode. Okay, the laser output depends directly on the drive current. Okay, the laser output depend on the directly on the drive current. Okay, if you change the current, the light change also. So how it is done? The function generator, by using the function generator, mm, by using the function generator or signal generator, make a modulation signal. So like a sine wave or data a square wave, the signal is fed into the laser driver circuit and the driver change the current going into the laser and the laser diode output light is modulated accordingly. Okay, what get modulated? So when the driver current changes, the intensity modulation, increasing the current, light become brighter, decreasing the current, light become weaker. Okay, this is the most common type. So frequency modulation is current change slightly shift the laser frequency. Okay, why direct modulation? Why direct modulation? Because the modulation signal directly control the laser current. No external optical modulator is used. For example, if you apply a square wave from a function generator, the current switch high, laser on, current switch low, the laser off. This become a digital optical signal. So advantage simple and this one. So you can see, once again we can see what is this. So direct modulation is when the current before reaching to the laser diode is modified with desired signal for the application. Okay, this use a function generator to create a this use a function generator create a modulation signal when the modulation is imposed into a laser after the light is generated. Okay, modulation such as electro optics modulation, acousto-optic modulation, and the electro-absorption modulation can be used to manipulate the laser output with the electric field or sound wave. Both are the example. So these are the example for the external modulation. So let's discuss what is the external modulation. So what is the external modulation? So external modulation is when the laser produce a continuous light and the modulation is applied after that light is generated using a separate optical device. So laser and the laser diode work in a continuous wave. The external modulator shape the light accordingly to the desired signal. Okay. So external modulation is when a laser produce a continuous light and then after the modulation is applied, after that light is generated using a separate optical devices. Okay. Okay. So external, example for it is external modulator. Okay. So electro-optics modulator use an electric field to change the intensity, phase, and polarization. Okay. Acosto-optic modulator, acosto-optic modulator, which produce a sound wave to control the light and produce an intensity of modulation, frequency shift, and the beam deflection. Laser driver, okay. Continuous wave is provided to the laser diode. Modulator light output. So let's see modulation and demodulation techniques schemes. Okay, when we have different kind of modulation scheme like ASK, FSK, PSK, and all analog data schemes support both modulation techniques. Okay, so here we so ASK modulation scheme are the amplitude shift king, frequency shift king, phase shift king. Okay, so amplitude shift king where the amplitude of the carrier have been changed. Okay, and the use mostly digital signal. Okay, frequency and the frequency of carrier is changed depending on the data. Use both analog and digital. One for the higher frequency, low frequency. Phase for the carrier use high performance zero phase, and one use for the zero phase. Okay, and zero use for the 180 degree phase. So okay, so what happened? Data input provider FM laser, the FSK. Data input provider master laser give the frequency modulator, then FSK signal. Data input is given electro phase modulator, the master laser provided the PSK signal. Okay, transmitter configuration. Okay, demodulator schemes. Okay, demodulation scheme. So we have to study demodulation scheme in the next chapter. So let's see the modulation scheme. After that, visible light communication. The visible light communication referred to the communication technology which utilize the visible light source as a signal transmitter. It is referred as a communication technology which utilize the visible light as a signal transmitter and the air as a transmission medium. Okay, and appropriate photodiode as a signal receiver component. Okay, okay. The visible light communication refer to the communication technology which utilize the visible light as a transmitter and air as the transmission medium and the appropriate photodiode as a signal receiver component. Okay, visible light is a form in which the electromagnetic radiation with the wavelength in a particular range is interpreted by the human brain. Okay, visible light is a form of electromagnetic radiation with the wavelength in the particular range interpreted by the human brain. The visible light is thus by definition compared to visually perceivable electronic wave. The visible spectrum covers the length of 380 nanometer to 750 nanometer. Okay, so visible light communication, in which visible light communication refer to the communication technology which utilize the visible light as a signal transmitter, air as a medium, and the appropriate photodiode for the receiving component. Okay. So visible light in the form electromagnetic radiation, the wavelength in particular range intercepted by the human brain. The visible light is definition as compared to visually imperceptible electronic. The visual light spectrum covers the range of 350, 380 nanometer to 750. Okay. Okay. Let's see a data modulation ppm sc. Okay, data modulation thing, light source, pd, demodulation, and the data received. Okay, so led and laser use as source for the vlc. Visual light communication, use of white light based on the led and wavelength converter. LED use both communication and the illumination to perform using signal device. There are communicator, amplification circuit, optical filter, and optical concentrator. Okay, beam diverse due to okay beam diverse due to the illuminating range area resulting in the attenuation. Okay, these are just simply definition or the theory based questions. Okay, VLC system. So VLC leafy alternative for sensitive or hazarded environment like airplane, hospital, and the industrial gas. This one employment of the RF technology is not permitted. VLC based indoor navigation service offer very high accuracy within a few centimeters. No harmful radiation. No public health concern. Okay. So VLC architecture consists of the physical layer from the application layer to the MAC layer to physical layer. Okay. Then after the data goes from physical layer to MAC layer and then application layer. Okay, physical layer task. The physical layer task is a modulation on off keying PPM and the PWM when data drive LED for the transmission through the optical channel. Okay, wavelength division multiplexing. Okay, subcarrier multiplexing, bidirectional transmission, orthogonal frequency division multiplexing. Okay, quadrature amplitude modulation to increase the data rate. Okay, what is the MAC layer task? Mobility support, dimming support, visibility support, security support, scheme for mitigation for flickerings. Okay, color things and the network backbones generation and device. Okay, all these things. Modulation. There's two type of modulation. PPM, pulse position modulation. This one and the frequency shift keying. Frequency shift keying. So modulation technique is on off keying. So modulation technique is on off keying. Pulse modulation. Okay, pulse modulation. PWM with a discrete multinode. PPM, pulse position modulation, multiple PPM. Okay, expurgated PPM, multi-level PPM. Color shifting challenges, flickering mitigation. Okay, flickers, maximum flickers. Okay, modulation things. Challenges, high path losses, multi-path induced in artificial light induced interference, LED electro optics responsive non-linearity. Indoor VLC scenario. VLC advantage: low power consumption, low bandwidth, no health concern, inherent inheritance, security, indoor localization. Okay, human safety, high data rate. What is the VLC characteristic? What is VLC human? Again, go through this video. So what we have. So first of all we have to on the advanced communication. So in advanced communication, this one we firstly have to fundamental of the coherent system. We have studied the fundamental of the coherent on the coherent system. Coherent system. Coherent system. What we studied. So what we have studied in coherent system. So we see the what is the definition. Okay, definition, condition for transmission. First of all, cover and definition. Okay, definition and the three condition for the transmission. So three condition for transmission is frequency, vibration, phase. So that is mm, that is that is frequency, vibration, and phase. Okay, phase. After that, as where we have there are two type of things. So we have studied what is homodyne and heterodyne. Then after we have studied what is homodyne and heterodyne. So homodyne and heterodyne. Okay, Homodyne and heterodyne. After that, what is intermediate frequency? After that, what is intermediate frequency? IF, that is intermediate frequency. Okay, intermediate frequency. So intermediate frequency, difference between frequency of incoming and the local oscillator. Okay, or add to the optical this one, detecting or resulting in the photo current replica. Okay, conventional of electronic technique used for this one. The ideal coherent receiver operating at this one. Okay, then after that it improved this one, advantage for the long this one. Now we see the block diagram for the coherent system. So block diagram now for the coherent system in which we in which we saw in which we saw the electronic in which we saw the optical select and drive electronics, in which we see the drive electronics okay, drive electronics. Then after the data is goes to the modulator portion modulator modulator portion. After that modulator, the things the data the lambda 1 comes from the see lambda, the lambda 1 comes from the uh, lambda 1 comes from where? Continuous wave laser continuous wave continuous wave laser and the laser control. Okay, then electron modulator and this laser control. After that the output side lambda 2 come from the local oscillator, lambda 2 come from the lambda 2 come from the local laser oscillator, and then photo detector response to this one, and then detector responses to and check homodyne and heterodyne. Okay, homodyne and heterodyne things. Okay, homodyne and heterodyne. Then it return the data output, then data out. Okay, so this is a block diagram. Okay, in which we see data in electronic devices, modulators, things produce a lambda 1 through the continuous wave through the transmission side. Okay, data response side amplifier, and the data is output as expected. So report different modulation format. So after that we see the different modulation technique, modulation of coherent system. Okay, modulation of coherent system through what? From the ASK PSK coherent system. Then we explain the block of coherent system. Explain the block of coherent system, transmitter portion and the receiver portion. Okay, then we move forward for the coherent principle. This is one for the fundamental of this one. After that we have to study focus on the coherent detection principle. So focus on the coherent detection principle. Coherent detection principles. Okay, coherent detection principle in which we saw First of all, understand the transmission. So what is this intro? The transmission detector receives the data from the modulator signal by using photo detector and the local oscillator. So the for this one, first intro, what is the principle? So in which see a technique to receive the it is a technique to receive the data from the modulator signal. So intro in which way it is a technique. So it is the technique to receive the data from the modulator signal by using from the modulator signal from the modulator signal. Okay. So intro is cover the basic current receive the model. Then we have to understand the formula for the incoming signal and the formula for the incoming signal. For incoming signal es, that is es is equal to cos of omega t plus phi. Okay. And the formula for and then after the formula for the formula for the local oscillator laser, the local oscillator laser. Okay. So its formula is el is equal to el of cos of omega t. Okay. Okay. After the formula and the low level inquiry, then combine the es, and after combining the es, so e is equal to es plus el here. Okay. All this thing happen. Understand the definition. God. All the definition and explanation of es, el, capital el, so capital es, capital el. Okay. All these things. Okay. Then based on different condition, based on based on based on homodyne and heterodyne, based on heterodyne we have to evaluate the formula. Okay. And furthermost we have to create, and furthermost optical detector produce this signal current. So after that after that after that we know about the we know about the photodiode current. So photodiode optical detector produce a photocurrent. So in which we have to know about the photocurrent formula. Okay. Formula. Okay. Proportionality. Then derivation thing happen. Okay. Then derivation thing happen. So we derive the formula till get the formula based on is. So at finally we get the formula. Finally we get the formula of is. Is is equal to is we get at 2r square root of what, ps and pl cos phi. ps and pl cos of phi. Okay, okay. Finally, we got the formula 2. Okay, so till here is the only things in the coherent detection principle. Okay, then we move to the next part. Next part, that is modulation and demodulation thing. So modulation and demodulation schemes. Okay, so modulation and demodulation things. So we see the modulation techniques. So in modulation technique we see the direct modulation in which we see that the so before reaching to the ladder, the current is modified. So in that technique, the current is modified before reaching to the laser. Okay, that this one, and indirect, yeah, external, indirect to external, indirect. So the modulation is imposed into the laser after the light generated. External things, when we modulation thing happen modulation thing happen after after the okay, light produce the things. Okay, and by the different technique, EOM, AOM, so different technique, by using different technique like EOM, AOM techniques, like, okay. And the laser diagram. So diagrams diagram diagram for the modulation and external modulation. Okay, diagram for the external modulation and direct modulation. After that, a modulation schemes different modulation schemes. So in which we see that ASK, PSK, FSK. So how this thing happen, and their diagram of things these things. Okay, diagram of these things. And then we have to understand, so modulation thing happen, then we so demodulation things happen, demodulation scheme. So demodulation scheme. Okay, demodulation scheme. So demodulation schemes are there. Okay, demodulation thing. And then after we have to study, after this we have we see mm, we see what is VLC. Okay, VLC. So VLC is a VLC stands for the visual 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 light communication, in which visual light communication things happen. So first of all, see the definition of what is visual things. Refer to the communication technology using the light as a air as a medium and the photodiode as a receiver. Okay, see the intro for this one. So light as a communication, air as a medium. Okay, and photodiode as a photo diode as receiver. Okay, Visible light is the form where electrons. So and explain about the what is visible light things. Visible light things explanation nations. Visible light things explanation. Okay. Then after we understand the data block diagram, block diagram in which we see the workflow of data modulation, light source, data, then after modulation and data modulation and light source. After the light source, then after then simply you can see simply data demodulation and PD and data simply modulation and after the PD of these things. Okay, block diagram. Then explain the LED uses. So VLC system architecture. After that VLC system explanation, and after that VLC system. What is VLC system? VLC system, why VLC based on indoor navigation service offer the high frequency to few centimeters and this. Okay, and understand the VLC architecture. Then afterwards VLCs like application layer, okay, MAC layer and the physical layer. Okay, so these are this one, the proper explanation of this one. What is the task of physical layer, MAC layer. Okay, then we see the modulation techniques, PPM, and then after we see the modulation technique. So that is PPM and the FSK, PPM and FSK, and the challenges. After that we completed the modulation thing, then we have to see the challenges. So challenges is flickering things, flicker prevent by using the change in brightness. Okay, uske बाद maximum time period within which the light intensity has been changed, modulation format, flicker mitigation. Okay, high path loss, multi path induce, artificial light induce. Okay, high path loss, these are the challenges. After that, what are the advantages, challenges? After that we see have to of VLCs. So VLC advantage, what is this? Low power consumption, low bandwidth, no healthcare concern, indoor localization. Okay, after understanding what is characteristic and demerit, same as a characteristic of VLCs, characteristic of the VLCs and demerit applications, and finally we cover this one. So we see at in advanced optical communication system, you have to understand the fundamental of coherent system. Then after the coherent detection application, then we have to move for the modulation and demodulation scheme things. Okay, direct and external things, and then we have a VLC's visual light communication. So in during the revision portion, we have to try to cover a maximum portion and maximum definition things and derivation thing of this one. So this is the flowchart.